Welcome to this Level Up Skills Series video. The topic today is the sine rule. We're going to look at what the sine rule is, how it applies to triangles, how we can use it to find those missing angles and missing sides, and we're also going to look at something called the ambiguous case, which is a slightly different adaptation. So have a piece of paper and pen ready. It's also useful to have a calculator ready, and we'll get started. Now the sine rule is a mathematical formula used to find the lengths of a side or the size of an angle of a non-right angle triangle. And that's the formula there. So it's a over sine A equals b over sine B equals c over sine C. Now this formula can be flipped over, so you can put sine on top, so you could have had sine A over A, sine B over B, and sine C over C. And that's relevant to any non-right angle triangle. And again, just what the notation means. Capital A, capital B, capital C mean the angles, so A, B and C, and then little a, lowercase b and lowercase c are the sides opposite those letters. So angle A, capital A, is opposite side A, which is lowercase a, and continues for B and C. Now we don't have to remember the formula, and it's good to understand what does the formula actually represent. What this essentially tells us is that the proportion between the side and the sine of the angle opposite it is equal regardless of which side we pick. So no matter which side we pick and which angle we pick, the side and the angle opposite in any triangle will be an equal proportion for that given triangle. And we can use that then to find out missing values when we have three values and we need to find the fourth one. So let's look at some examples. Now first we need to understand, well, when does the sine rule work? And the key thing is, because of those proportions, that A over sine A, B over sine B, C over sine C, we have to have what we call a matching pair. That means we need to have an angle, we need to know that number, and we need to have a side, that side directly opposite it. So if we look at this triangle on the left, we've got this pair here of 14 and 81. That's a matching pair because we've got the side and the angle opposite, so the sine rule works here. If we look at the question on the right hand side, we have an angle, we have two sides, but opposite our angle, we don't know what length that is. So therefore the sine rule doesn't work in this case. Now in this case, if the sine rule doesn't work, we use something called the cosine rule, which we cover in a different video. But for the purpose of this one, we're looking just at the sine rule, so we can see that we have to have that matching pair to see if the sine rule works. And if that doesn't, we then have to try something different. So looking at this first example, we've got a non-right angle triangle. We're asked to find the value of x and give our answer to two decimal places. Now this is the example we had on the left in the previous page. So we know we have that matching pair, so we know the sine rule is going to work. Now that sine rule is a over sine A equals b over sine B equals c over sine C. Now we could go and label this triangle A, B, C, but actually it's easier just to understand the proportion that comes up in this formula. So if we have a look at this question, we're always going to have a fraction is equal to a fraction. So we've got some fraction is equal to another fraction, and we know these fractions are going to be equal. What I like to do is I put the first unknown, so that's my x, that's going to go in the first position, that top left position. Then to finish that fraction, opposite that x is my 59, and I know that my angles will always go with sine, so that's going to be opposite sine 59. Then using the other matching pair, I'm going to build a second fraction. So x was a side, so I'm going to use 14 as my side to go on top of my next fraction. And then that's opposite the sine of 81. So that's it set up for us. The reason I like my x to be in that top left position is because now my next step is always going to be the same no matter what question I have. I'm going to take that sine 59 and I'm going to multiply it on the other side, because on the left hand side it's dividing, so on the right hand side it'll be multiplied. So we have x is equal to 14 over the sine of 81 multiplied by the sine of 59. And then from there we just put that value into our calculator. We can do all of it in one go, and that gives us an answer of 12.149, which if we round to two decimal places is 12.15 centimeters. So again, the key here is remember that x is always going to be in that top left hand position, and then that first step is just going to move the denominator across to the other side. Now in this second example, we're going to look and see, okay, have we got a matching pair? And we have. We've got that 32 degrees and that 5.3 centimeters. So we've got our matching pair, so we know that this one works. Now, in this case, our x is an angle. So it's going to look slightly different. We've got one extra step to do, but we're going to start in exactly the same way. A fraction equals a fraction. Remember, I want my x in that top left-hand position. But because x is an angle, we don't want x on its own because our angles are always going to be attached to sine. So it's going to be sine of x over, well, the side opposite that is your 7.5. And then we're going to make our second one, our angle goes on top, so sine 32 over 5.3. Now our first step is always going to be the same. We're going to bring that 7.5 across to the other side. So sine of x is equal to sine of 32 divided by 5.3 multiplied by 7.5. Now what you'll notice here is we don't have x equals like we did in the last question. We've got sine of x equals. And if you've got experience with trigonometry, which I'm hoping you have, you then know, well, actually, because we're finding an angle, we need to use sine inverse. So therefore, we have x is equal to sine inverse, or sine minus 1, press shift sine in your calculator, and then you can put this whole thing in one go. So sine 32 over 5.3 times 7.5. And then in one go, you can put all of that into your calculator, and that will give you an answer of 48.580. And again, our little ellipses to say that number continues. And then we're going to round to one decimal place. So x is equal to 48.6 degrees. And that's the angle in that case. So remember, we always want that unknown in that top left-hand corner, and that sine is always going to be attached to our angles. So now it's your turn. Here's two questions for you to try. Take a moment, pause the video, try the two questions, and then come back and check your answers. So hopefully you've had some time to practice those questions. Let's see what we would have got as our answer. So in our first one, we want to set up our fraction. So x over sine 38, we want that unknown in that first position, is equal to 12.3 over sine 92. When we rearrange that, we get x is equal to 12.3 over sine 92 multiplied by sine 38. And again, you might have brackets on your calculator that you just need to close when you're doing this, so just double check whatever your calculator asks you to do. Then on your calculator, when you get your answer, you're going to get an answer of 7.58 centimeters to 2 decimal places. Similarly with the second question, our unknown in the first position, so sine of x over 10.7 is equal to sine of 23 over 6.4. And then when we bring our 10.7 across, and remember we're finding an angle, so we're going to do sine inverse as well, our rearrangement should be x is equal to sine inverse of sine 23 over 6.4 multiplied by 10.7. And if we put all of that into our calculator, we get an answer of 40.8 degrees. And that gives us our final answer to 1 decimal place. So again, making sure that we always put that x in the top left-hand corner, rearrange it, and solve for x. Finally, when we're doing an angle, remember it's sine inverse at the very end to find out what that angle is. So the final question we're going to look at is this idea of what we call an ambiguous case. And this is where it says x is an obtuse angle and asks you to work with the value. Now, anytime we do the sine rule, it will always give you an acute angle, and it's how do we convert that into the correct obtuse angle. But if we start this question, we start in exactly the same way. We've got sine of x over 10.2 is equal to sine of 55 over 8.7. Solving that and rearranging, we get x is equal to sine inverse of sine 55 over 8.7 multiplied by 10.2. If we put that into our calculator, we get an answer of x is equal to 73.8 degrees. Now that's an acute angle, it's less than 90, it's not obtuse. So to find our obtuse angle, we will always do 180 degrees minus 73.8 degrees, and that will give us our answer. So we do 180, take away that, and that gives us 106.2 degrees. So the actual angle for x is 106.2 degrees. So anytime it asks you to find the obtuse angle, you work it out. It will always give you an acute angle as your answer, or usually, and then you do 180 minus that to give us the answer. And that's because sine will always give us an answer that's between 0 and 90. I hope you found this video useful. There's plenty more on the channel, so please feel free to click on those and see what you want. And hopefully we'll see you in another video.